All right, guys, this is Mr. Floodstrom here. I want to go over, this is Earth Science TK12 3.15, Earth's crust. I want to do a little quick review with you, and then I'll give you, show you the demonstration. So I'm going to go over here, and I think you can see it now. Yes, okay. So here's what we have. This is just a quick review, and actually this is going to be, this is going to be Earth Science CK12. This is like 3 point, oh dear, 3 point maybe 12. Oh, sorry, 3.12 to maybe 3.15. All right. They talked about the four spheres in terms of the Earth. Here are your four. You have the atmosphere, which is the air portion. The atmosphere, most people would think, if I asked them, oh, what gas is the dominant, the greatest abundance? I think a lot of people would think oxygen, but actually oxygen's only at 21%, while nitrogen's at 78%. So you add those two up there, you get 99%. So 1% is carbon dioxide, argon gas, a few others, trace gases in there. So that's your first sphere. The second one is the lithosphere or the geosphere. Lithos means rock, geo, earth. So these are the same, geosphere. This is the land portion. Number three, you have your hydrosphere. Hydro prefix means water. So, and sphere means round. So this is the water portion. This is all your oceans, lakes, etc. And the fourth element, or the fourth sphere, is your biosphere. The prefix bio means living things. Living things would be your plants, your animals, fungi, protists, bacterium, okay, your coronavirus. Well, I don't want to get into viruses. Okay, so let's go to the next one here. Okay, so the layers of the Earth, okay, the layers of the Earth. And predominantly there's three. Sometimes people say four, but I kind of think there's like mainly three layers, and then they break them down. So the first, the innermost layer is the core. Okay, so the core, but then there's two types of core. There's the inner core and the outer core. So you can see this. So obviously this would be the inner core. Oops. And this would be the outer core. Inner core, outer core. I'm going to do that. Now, as you can see this, they're made of metals, okay? And this goes back to the birth of the Earth and how, the theory out there in terms of it was this protoplanet and there was these collisions but one of the components in terms of, if you look like asteroids, is they're predominantly metals, and the metals are iron and nickel. And just like anything that's heavy or dense, it's going to settle to the bottom or to the middle. So this is why within the Earth's core, the inner core and the outer core, the entire the core is made of metals. Now the difference is the state of matter. The inner core, this is a solid, okay? And the outer core is liquid form. Now, why the difference? Well, in the inner core, there's a lot of pressure because you got to remember, right? You have the this gravity is an inward force. And so it's all, this inward force. And then also you have all this mass that's compacted, down into this area. And so this is under great pressure. So this is a solid. The outer core, which is a metal, this is actually more of a metal. I will tell you about both of these, though. They're extremely hot, super, super hot, okay? That's important. That's going to be the engine that drives the movement of the movement of the plates. Okay, so core, the second layer is the mantle. Here's the mantle. This whole area here is the mantle, all right? And the mantle is liquid form. And there's kind of what they call an upper mantle, and then there's the lower mantle, okay? Actually, the more I think about it, this is the lower mantle, this this like tannish color. And this would be the upper mantle. That'd be upper mantle right there. Now, like we said, it's composed of melted rock and magma. Magma is melted rock. Okay, and then the last one, the third layer, is the crust. And that's the outermost layer. It's in the form of a solid. Okay, now this crust isn't one solid piece. It's actually broken into 12 main plates. Okay, there's more than 12, but these are like your 12 major plates. And since it's broken, these plates are moving because it's a solid, right? The crust, and it's kind of floating on this liquid portion of the upper mantle. So things are moving. That's why you have earthquakes and you have volcanoes and trenches and building of mountains. Okay, let's go to the next one. So this breaks it down a little bit more. Your crust, the main part about this, there's two parts to the crust. There's two types. You have your continental crust, and you also have your oceanic crust. All right? And this kind of goes through this. You can see this. Now, the one thing I want to make note is the two, like, what's the main difference between the continental crust and oceanic crust? Okay, first off, the oceanic crust, this crust here, they say in terms of thickness, it's anywhere from 3 to 8 miles thick. All right? And it's extremely compacted, lots of pressure, so it's very dense. Very, very dense. And it's a solid. Remember, it's a crust. It's a solid. And it's predominantly basalt. Okay, basalt, which is a type of rock. It's when magma cools. All right, so there is your oceanic crust right there. Those are the two key points. How this is fairly thin, 3 to 8 miles, and it's very dense. Now let's look at the other crust. The other crust is this one here, right? There's your continental crust. And here's the key points to your continental crust. And I don't want to confuse you, so maybe I should, I'm going to kind of do this. Don't want to confuse you over here. So there's two types, and one we said is the oceanic. I'm going to write that here. Oceanic crust. There's one. And then the other one is your continental crust. And here's the two key points. This is thicker. It's around, I don't know, they say about 36 miles thick. So it's more thick than your oceanic. And it's also, it's less dense, okay? So it's less dense, and that's going to have an impact on when there's collisions between the different plates. All right, next slide. All right, now this is going to kind of go through, I'm going to do a demonstration, but we know that there's constantly movement. So the plates are moving, okay? They're moving. And you think, how in God's name? These are continents. How are these continents moving? But it's true, they are. So what's the engine? What's driving it? What's causing it to move? Well, inside the core, right? Inside the core, we said it's super hot here. Really, really hot. And we know this, the mantle, is this liquid, right? This liquid. And any liquid, or sorry, anything that's a fluid. So a fluid can be, you know, either a liquid or a gas, liquid or gas. And we know that the mantle is a liquid. And so what happens when you start heating something up, right? The molecules of that liquid, they start to increase in energy, and they expand. And when they expand, they become less dense, and then they rise. Okay, so that's what's happening. You see that this rising. And then what happens is it gets up here by the crust. And if there's a weak spot, it may push through. And then you're going to have the formation of volcanoes or perhaps islands. Okay. But then these plates are also being pushed because it's almost like being on a conveyor belt. All right. And then you can see that over here, then it starts to cool down. When things cool, the molecules lose energy. They get closer together, more dense, and it drops. So this is the engine that drives these plates. All right. This is just kind of showing. So if this is your heat source, this is the heat. You're going to have it where if you're heating this up, this area, right, it's going to rise here, right, rise up. And then once it gets to the top, it cools down and it sinks. And you get what these are called convection currents. And convection is one way that you heat a fluid. Convection, conduction, and radiation. Okay, now I want to show you my come on here. Let me do this. Can I go this? I want to go to back to stop presenting and go to me right there. Yay, here it is. Okay, hopefully this thing's still running. I hope to God it is. Is it still recording? I think it's still, yeah, it's still recording. Okay, so here's what we have. In the back, can you see this back here? It's kind of cool. This is a lava lamp. It's a lava lamp. I'm going to turn off the lights just for a quick second. And you're going to kind of see how this works. Very simple. It's plugged in. There's just a little light bulb down here. And then in here, this fluid, it's kind of an oil. And then this is like a wax. This is like a wax. And when you heat this up, then the wax starts to expand and becomes less dense and it rises and comes down. So maybe you have one of these at your house. They're really cool. They're a little bit dangerous though. So maybe you can see it a little bit there. As this thing gets really hot, it breaks into these little globules and it rises and sinks, and it's a pretty cool thing. All right, now find the lights. There we go. Okay, here's the next thing. This is called a convection tube, glass tube. Here's what I'm going to do. I'm going to fill this up with water. Fill this up with water, and the water temperature is just like cool water. I just got it right from the sink, from the faucet. And here we go. Get the air bubble out of there. There we go. It's all water all the way to the top. Get it all the way to the top. And now here's what I'm going to do. I'm going to hold it like this. I've taped it. Dear God, I hope this doesn't fall. This is like 20 bucks. It's expensive. And what I'm going to do is I'm going to drop in a drop of food coloring. And I want you to watch it as it starts to come down. Then what I'm going to do is I'm going to put a lighter onto one of the two sides, either here or here. And then I would like you to predict, or as it's going on, which way is it moving and why? Okay, which way is the dye moving and why? So let's go over here. Let me open up this cap. Let's go with red. I want to contrast. So here's my drop of red. See it going down? So it's spreading out. What tells you that dye must be more dense than the water? Because look, it's coming down, isn't it? Gotta be patient. It looks like it's kind of leaning a little, it's kind of coming this way, isn't it? Maybe I have it at an angle, I don't know. But here's what I'm gonna do now. Just because it's starting to come down this way, I'm gonna start heating it right here. Oops. You guys see the flame? Make sure I don't catch my hand on fire. Keep an eye on that. Do you see that up there? No, that's just soot that's coming off there. That's just some carbon. But look at the movement. Look at the top right here. Look up there. Look what's going on. See it starting to go? Look at that. It's going down. Now let's see if I can stop it. Come on, baby. Come on. Right there. Heat that up. Heat it 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 up. Try to turn the course. Turn the course. Turn the course. See how it's going back the other way now? See it's coming down over here by my hand? You see how it's rising up? I don't know if you can see it's rising up. And now it's reversing the opposite way. You see that? Yep, now you can kind of see the movement. I could go back like that. That'd make life a little bit easier, wouldn't it? Okay, let's try blue. I want to go with blue. If I can find blue. What happened to my blue? Oh, here it is. Let's just give it a go. I didn't even see it. Hold on, I'm going to dump this. All right, let's go. All right, I gotta hold it back like this. You have the white background. Here we go. Come on. Atta girl. All right. Oh, gotta drop in the blue food color. Here we go. All right, that's kind of cool. You see that? Okay, now I'm purposely gonna wait till it hits the bottom. All right, now I'm gonna start heating it up right here. Keep an eye up there. Which way do you think it's gonna move? It's gonna go left or right? Keep an eye up there. Uh-oh, see how it's moving? You see that? See how it's moving? It's kind of cool. Reminds me of the old movie, The 10 Commandments, where the plague descends upon and kills all the firstborns. Look at that, here we go. Isn't that neat? So you can see the motion. Look at that current. So what's happening is I'm heating up this water right here in this corner, and that water right there is gaining energy, and it's moving faster and it's spreading farther apart, and it's rising. It's heating up the water, and that warm is rising up and creating that current. You can see it's all of a sudden gonna be one solid blue mass. You got that motion going. All right, I think that's good. So that's called the convection tube, and thank you for following. All right, let me shut this down here. Bye-bye. Stop recording. Boom.